So in this video, we're going to start looking at bile. How is bile created? What is bile? Why does it matter? So we're going to look a little bit about what are bile salts, what is bile, the fluid itself, and then we'll look a little bit more in detail about how it actually works and what the bile recycling system is.
So here we are talking about bile. So you can see here in this H&E staining, we have our hepatocytes and our liver, and here we have our bile ducts, and this yellow stuff is the bile. We see there's bile here, and you see some sort of floating around in these various places. So what bile actually is it's a liquid, so it's mostly water, but it has in it these lipid micelles. And these lipid micelles that we see here have this lipid component, and then they're surrounded by these bile acids, which have a hydrophobic side and a hydrophilic side. And what this means is they can surround these lipid micelles with their hydrophobic side encountering the lipids and the hydrophilic side encountering the water. And this prevents the lipid micelles from coming together and forming large lipid globules. It also means that this hydrophilic side helps to maintain this as a liquid, and it also helps to dissolve large water-soluble molecules, as these are charged components. And so this allows those water-soluble components to interact with those as well. This becomes this liquid that has these micelles in it, which is a characteristic of detergent, right? Is having these lipid components as well as charged components. So that means lots of different kinds of molecules can be dissolved into bile. So those enzymes can get into here, as can things that are lipophilic, as can things that are hydrophilic, right? So we have a whole range of things that can all be dissolved in these bile acids, this bile. So what are bile acids and how are they made? They are synthesized in hepatocytes from cholesterol. First step in this, inside the hepatocytes, is there's this 7-alpha hydroxylase, sometimes this 12-alpha hydroxylase. And what these do is they hydroxylize parts of these. So in this case, you see we're adding these OHs to a couple of different places on these ring structures. There's also some dehydroxylation going on, etc. And so what's going on is this is changing the structure a little. And then these are secreted into the bile, go into the bile duct, eventually into the gallbladder. When these are secreted from the gallbladder and into the intestines, there's some the bacteria in there can make these secondary bile acids. These are secreted out of the hepatocytes by an ATPase transporter, which is just like the ABC transporters and the ATPase transporters that we talked about. The main one involved in this is the bile salt export pump, BSEP. So bile salts don't go and get disposed of. They get reused. They start off here in the liver, and then they go to either directly to the small intestine if you're busy eating, and if not, then it's always constantly being made, and they'll get stored in the gallbladder. The sphincter of Oddi will open when you have stuff to digest and will close when you don't, and that either sends things to the gallbladder or to the small intestine. The bile gets released into the small intestine where, again, because it's all of these micelles and it's got enzymes and stuff in it, all of these things help to break up and dissolve and make soluble in some fashion lots of the things that we want to eat and lots of the components of our food. In this process, however, these bile salts get removed and get moved around, get changed a bit. And as all of this happens, then they also get uptake again through the ileal. Right, so down here at the bottom of the small intestine, there are transporters that will bind to the bile salts and uptake them into the portal vein, which of course then goes back to the liver. So the liver can then uptake them from the blood in the portal vein. There's also some that gets uptake from the colon as well. But some of them do, of course, get lost, and we have to make more. The micelles that we mentioned are made up of phosphatidylcholine and cholesterol. These are secreted from the hepatocyte into this bile caniculi, or caniculus. Right here is one of them is a caniculus. These micelles, because they're large, they increase the osmotic pressure. And this osmotic pressure, by being secreted, active secretion of these micelles into the caniculi and the components of this, it will pull water from the sinusoids and other things as well that can pass through with the water through these tight junctions, which are not all that tight. So water, glucose, calcium, all those kinds of things can get through and into the bile from there. Not all of those things do we want the bile to contain. We want to keep a bunch of those, and so there's a bunch of transporters in the lumen of the bile duct that tries to pull some of those things back out. We want to bring the chlorine back in. We exchange chlorine for carbonates. We also use these chlorines that we've built up to bring back in things like calcium and cyclic AMP. There's pumps to increase water to keep the liquid fluid and moving along. And then we also keep the pH low, so the carbonates help to keep the pH low, which helps to keep the calciums in solution, which is good because that lowers our risk of gallstones.
From that video, there are a few things I want you to remember. So I want you to remember that bile is a liquid, and I want you to remember why. How are we getting all these hydrophobic things into a liquid? So you should know a little bit about what the bile salts are. You should know that they come from cholesterol. You don't need to know all of the details about how they go from cholesterol to bile salts, but you should know briefly what they are. You should also understand the biorecycling system. So how do they get out of the liver? And then once they're out of the liver, how do they get back into the liver? Right? So you should remember that a little bit, in part because that's really important for understanding how metabolism is working. Okay? So that's all that I really want you to remember from this one.